Good afternoon, everyone. I'm Nicole Henderson, Editor-in-Chief at the WHIR, and I'd like to welcome you to today's webinar. Today's session, called Top 5 Considerations for Transitioning to Open Compute, will be presented by HP's Director of Hyperscale Engineering for the Hyperscale Business Unit, Curt Belusar. Before I hand it over to Curt, I wanted to let you know that there will be some time for questions at the end of the presentation, but you can ask them throughout the session using the question function in the webinar software. You should see a box on the left side of your screen where you can ask questions. If for some reason you can't see that box, there's a red Q&A button at the bottom that will make it appear when you click on it. If you ask a question and it doesn't get answered because we've run out of time or maybe it's a bit too specific, somebody will reach out to you by email after the webinar. Finally, there will be a video archive of the webinar available if you want to rewatch the presentation or share it with someone else. It will be in the archives at thewhir.com/webinars by the end of the week, so make sure to check that out. You should get an email with a link to the presentation as well. Okay, let's get started. Welcome, Curt. Thanks for joining us today.
Okay, thank you for the introduction, Nicole. As Nicole mentioned, I am the Director of Hyperscale Engineering for HP's Hyperscale Business Unit. HP's Hyperscale Engineering team works with the largest internet service providers globally to develop massive scale-out IT architectures optimized for cost and for power efficiency. My team is also the team that has developed HP's Open Compute offerings. And we also are the ones that participate in the Open Compute Summits and work with the Open Compute Initiative from HP. So we've been getting a lot of questions about Open Compute from our customers, and so this webinar is designed basically to answer some of those questions, and especially for those customers that are considering Open Compute and wondering if it's the right IT infrastructure for them. So we're going to concentrate on what are the top 5 considerations if you're considering transitioning to having Open Compute gear in your data center. And I'm going to start off by giving a brief background on Open Compute. We have this listed, it says Open Compute, it's a religion, but part of the reason why we say that is that lately there's a lot of buzz about Open Compute in the industry, and there's a lot of customers that are interested in like the idea of open standards, whether that's Open Compute, whether it's OpenStack, or potentially OpenFlow and networking. And they're excited about the aspect of open standards, but they don't completely understand exactly what makes something Open Compute. And so Open Compute was an initiative that was started by Facebook as Facebook was going and building some new data centers that they had in Prineville, Oregon, and some other places. They developed the Open Compute standard, and Open Compute was morphed a couple years ago into a standards or specifications body, which was then became the Open Compute Foundation. Open Compute Foundation has a board of directors that charters the projects and appoints project committee chairs. And there's some different work streams that are happening within the Open Compute Foundation. There's server platform work streams that govern things like motherboard design for servers. There's a group that's working on management for server platforms. There's a work stream that works on rack infrastructure. We'll hear about something called OpenRack in a little bit. There's a team that also works on power supply distribution and UPSs. There's a work stream that handles storage, and then there's a work stream that handles networking. And we'll talk about most of these work streams as we go on through the presentation. So as one of the key folks within HP that interfaces with the Open Compute Foundation and ends up working quite a bit with customers on Open Compute, one of the questions that I often get is if customers will have heard about Open Compute, they're excited again about the idea of open standards, and there's a lot of interest, and they'll ask me the question, tell me about your Open Compute server. And that's kind of how they open up. And at that point, I've got to stop and back up and do a little bit of education, because there's not just one Open Compute server. or even one open compute infrastructure. So it's important to understand that as we talk about racks, as we talk about power distribution schemes, and as we talk about the servers themselves, that there are multiple options. If you look, the initial rack that was developed for open compute, Facebook developed a rack that they called triplets, which were kind of like 3 racks welded together. And Facebook typically deployed those in, again, this triplet form factor with what they call a blue battery cabinet. And later, they developed the standard Open Rack that was, again, later adopted by the Open Compute Foundation. And the first version of Open Rack, you can see that there's a version that's shown to the left in this slide that has what we call 3 power zones. And each power zone has 3 bus bars. But what a power zone is defined as is a section within the rack that's powered from a particular power shelf. And then there are 3 bus bars coming up from each power shelf that are used to power the servers. More recently, within the Open Compute Foundation, there's work to look at some different Open Rack options. There's a 2 power zone option, and they're looking at narrowing down to 1 bus bar for cost savings. There's another variety of Open Rack out there that has basically 1 power zone. That means only 1 power shelf within the rack, and they actually have 3 bus bars still going up and down Open Rack. We'll talk a little bit more about the specifications and dimensions around Open Rack. It's just important to understand that there's more than one flavor of Open Rack out there in the industry. And the same thing goes for the server side as well. So within Open Compute, as I mentioned, the motherboard specification workstream is one workstream within Open Compute. And they've got some motherboards that basically go in 19-inch rack systems, and they've also got motherboards that are designed with different form factors that are used in the Open Rack as well. And so one of the servers that you'll actually find if you go out and you look on the Open Compute website is you'll see some drawings that talk about third width servers. So they've got third width servers with what we'll call basically a 6.5-inch wide motherboard or a third width motherboard. There are also servers out there that have half width, so half rack width motherboards. We'll talk about some of those. And there are even some servers that fit in 19-inch racks. So it's not, the point here is that it's not just one server or one rack. And you have to have an idea of the application that you're wanting to target the servers for, and also an idea of how much power you have available per rack, or when you load up the servers that you selected that are matched up with the workload and application that you have, about how much power the rack's going to draw, so that you know which power distribution scheme to select. So just a little bit of background there so that everyone understands it's not just one Open Compute server or even one rack and power infrastructure. There are options. So jumping into some of the things that you need to consider if you are considering having Open Compute infrastructure in your IT environment. And we're going to talk through what the top 5 considerations are. The first one that I have listed is scale and volume. And the question here is, do you have enough scale and volume to make it make sense to lower your total cost of ownership enough where you think that it is a good idea to go switch to Open Compute? OCP platforms today are designed, built, and they're shipped to a few customers. And more specifically, they're built in batches today. These very large customers will order a batch of Open Compute servers, and they're essentially batch put through assembly. And so the question is how does your buying pattern line up with these batches? Or if you're buying a small quantity, how does that work with this kind of model? More importantly, a lot of customers will look at the Open Compute design, and then they'll say, I like the Open Compute design, but I'd like to have this feature added, or I'd like to have more hard drives accommodated within the server, or I'd like to have a different PCI configuration inside the server, so I can plug some different options in. And if you want any material change to the configurations that exist, you'll have to consume those servers in volume, essentially, to help justify those changes that you potentially want. If you look and you see an Open Compute server that exists already, and it matches exactly the configuration that you need in your IT environment, then that might be fine. You can potentially piggyback on a batch build, but this is something that that you have to think about. We'll talk about supply chain concerns coming up on one of the slides that we're going to get to in a few minutes, but that also implies that you'll want to consume Open Compute in volume. Otherwise, you've got some real constraints. So another or second consideration is is it a practical and good fit for your environment? We talked about OCP racks a moment ago, and we talked about Open Rack, which is one of the work streams within the Open Compute Foundation. Open Rack currently has 21-inch width from internal rail to internal rail, and so that's about 53.8 centimeters wide. Industry standard racks that have been around for many years are based on a 19-inch standard. And then from increments of height, a lot of people talk about rack units. Rack units in a standard 19-inch rack are on about a 42 millimeter pitch, 43 millimeter pitch. And in Open Rack, they basically defined that the height increments or the units is what they call open units, and those are on a 48 millimeter pitch. Furthermore, in an Open Rack, you have your power distributed from the power shelf via bus bars that are sitting in the back. So basically in the back of the area where the servers plug in, you do have bus bars that are running vertically within the rack that deliver power. And so the key thing here is that you can't intermix industry standard servers, or what some folks will call generic 19-inch servers, with OCP servers in the same rack. An OCP rack is for 21-inch wide servers, and it's got these bus bars in the back. If you tried to plug an industry standard server in there, one doesn't fit. Even if you were to find a way to space it in there, then you've got bus bars in the back that you would run into. So it's not able to mix industry standard servers and OCP servers. And if you've got a data center that you've either are using a colo, or you've got a data center that's already got 19-inch racks populated, this is a concern that you've got to take into account. There's a few other considerations. OCP servers are front cabled. That means that it's not a problem for a lot of customers, but there's some concerns there. You've got to have your network switch with cables coming out the front as opposed to the rear. There's airflow things that you've got to think about. Again, there's many network switch vendors that accommodate that, but it's just something that you need to consider if you are going to go there. So these are some of the key things that you've got to think about. Is this a practical good fit? Are you able to accommodate a new rack in your data center? Do you have concerns about mixing and matching with industry standard servers? These are some of the things that you need to consider if you're making the switch to Open Compute and looking at bringing in Open Compute rack infrastructure. So consideration number 3 is, do you have in-house expertise? If you're going to consume Open Compute equipment, you're going to want to have people on your team who are knowledgeable about OCP specifications and who are potentially active in OCP. But you may need technical expertise, who is a little deeper than what you would normally have to understand servers and potentially networking, as you're looking at network switches that are going to be available through OCP in the future. or you may have to think about power distribution if you are looking at OCP and trying to understand how you're going to bring and distribute power into the power shelves within OCP, how many power shelves you need per rack. You're going to have to understand your rack power consumption. You're going to have to understand power consumed for a particular workload that you're going to land on the rack so that you know how to configure the rack with the power shelves. You're going to have to also think about how are you going to manage these servers. OCP management is a track within the Open Compute Foundation that's currently being worked, but there are standards that are evolving there related to management. You're going to have to understand how to use more standard scripting and some very basic industry tools that are available today. I've already mentioned a couple times why it's important to understand what your application requires, but you really do need to understand the workload so that you can select the correct Open Compute server and so that you can know from a power standpoint how to go configure the rack so that you can meet the needs of your IT environment. So it's important to understand that these standards are evolving. The rack specification is probably a good example. When Open Compute was initially first launched, there was a rack that, as I mentioned, that was called the triplet rack, and that was a 21-inch wide rack, but it did not have the power distributed from a power shelf. The next year, the Open Rack specification came out, and it was different. It had 21-inch wide rails, but it had power distributed throughout the rack in 3 power zones. Now we're seeing racks with 2 power zones, 1 power zone. That's an example of a specification that you would want to understand how it's evolving and changing, because it does affect how you go deploy servers in your data center, and which rack you select may be very important to make sure that it's matched up with the application that you have. But you're going to have expertise in that area to go track that specification as it changes and evolves over time. So you have to have in-house expertise within your company, and there needs to be probably experts in some different areas. Supply chain and global service and support are major concerns when it comes to purchasing Open Compute equipment. One of the questions that you've got to ask yourself is that since there are a few large customers today that consume Open Compute, you need to understand, are you wanting Open Compute servers delivered to a place where there's an established supply chain for them today, or are your Open Compute servers, are you going to have them integrated one place and delivered to another place? It's important to understand how that supply chain will work. And part of the reason why it's important to understand that is you want to go back and think about one of the things that you're potentially trying to address with Open Compute, which is cost of the server. And if we pause for a moment, maybe go a little bit off topic, but think about cost of the server. A majority of the cost of the server is made up of what we'll call commodities: processor, memory, and hard drives. That can be, depending on how your server's configured, anywhere from 55 to 75% of the server cost can be processor, memory, and hard drives. Those commodities are the same, whether you're using Open Compute infrastructure, whether you're using industry standard 19-inch servers. That portion of the cost structure does not vary. Open Compute does address chassis, motherboard, and, as we mentioned, some of the rack infrastructure. So you have to keep in mind that those are the parts of the cost infrastructure that you can operate on with Open Compute. And there are other multi-node infrastructures out there that also in 19-inch racks that try to operate on the same portion of the cost structure. But it's a minority of the cost structure that you can affect. But the reason why I bring that up on this slide is if you are wanting Open Compute servers in a part of the country or world where you don't have a supply chain established, that can actually make the cost go up if you're not careful, because also a portion of the cost of a server is labor and overhead that is associated with assembling different portions of the server, shipping, getting the server shipped from point A to point B, and labor and overhead again as you do rack integration. So we need to be careful from a supply chain standpoint that there is a supply chain established, or that the company that you're looking at purchasing the Open Compute servers has a global supply chain set up. Other things that you've got to think about are service and support. So if you're purchasing Open Compute equipment from a company that doesn't offer good global service and support, you may have to end up handling the service part yourself. You may need to be thinking about what happens when a part fails and you have to get a replacement part. Are you going to develop relationships with commodity vendors, with memory vendors, with drive vendors, so that you can handle warranty returns? These are things that you need to think about. One of the things that, as we look at the concerns that are listed on this particular page, if you do buy from a company like HP, HP mitigates a lot of those concerns because HP offers the same global service and support that we offer on standard servers on Open Compute offerings as well. But you need to look at who you're buying from, and you need to ask yourself some of these questions. And there are other Open Compute suppliers other than HP out there that you will have to think about. Will you be handling some of your own servicing in-house? Finally, you're going to have to think about the tools that are associated with these servers as you want to go and do large-scale deployments in your data centers. Do you have the right scripting expertise and the right expertise within your company to be able to handle some very basic management tools to go out and manage the servers once they're up and running? So these are some things that you need to think about if you're thinking about making the switch to Open Compute equipment. So finally, the number 5 consideration is participation in the Open Compute community. And the question that you want to ask is, how is the forward-looking roadmaps, how are the forward-looking roadmaps for the Open Compute community formed? And the answer is they're formed by a community. And that sounds obvious, but the impact to you is, do you have the time, people, and the money to participate in the Open Compute community? Do you have the time, people, and money to help shape the OCP standards and specifications that are going to happen going forward? OCP is going to continue to evolve. You need to have folks within your company that are staying up to speed on what the OCP standards and specifications are, making sure that you're continuing to determine that the direction that a particular motherboard or form factor is going in is a good fit for your workload. It's a good fit for your environment. You can imagine there are different processors today that are in development and on the roadmap, out 2 and 3 years. Those and I'll just use this as an example. Those processor sockets may come out. You may see different form factors. If they require a change in the form factor of the boards to make it, potentially a wider than a 6.5-inch motherboard, and you've standardized on having third-width servers, you're going to want to understand how the OCP community is going to respond to that. You may want to influence the roadmap to make sure that the answers turn out to be the right answers for your company. So the question here is do you have the resources, again, time, people, and money within your company to help participate in the OCP projects and help shape them to meet the forward-looking needs for your company? And this is something that you need to think about as you're potentially considering adopting OCP equipment. So just to summarize what the top 5 list of considerations are as you're considering Open Compute for your IT environment. Do you have the volume and scale to purchase OCP equipment? in particular, if you're going to want to alter maybe the feature set inside the box at all, do you have the volume and scale to actually go and drive that? Second is the practicality of implementation. And we talked about making sure that your data center would be able to accommodate open rack, or potentially a mixture of open racks and 19-inch racks if you're still going to want to have industry standard servers in your data center as well. And have you thought through that? In-house expertise. You're going to need some in-house expertise to be able to deploy and manage the servers, and potentially keep up with the different specifications that are coming down the road. Make sure that you understand the specifications and you can configure the racks and the servers the right way for your workloads or your needs and your applications and your environment. You've got to think about global supply chain and service and support. Again, if you're buying from a tier 1 vendor, some of that's mitigated, but you've got to think through that as you want to go and purchase the servers and have them delivered for your different locations that you may need them. And then finally, active participation in the community. You've got to consider actively participating in the OCP community so that you can actually influence the specifications and make sure that as they evolve going forward, that they're staying matched up with the needs that you have within your company if you've decided to go down the OCP path. So these are some things that you've got to think about. I'm going to go ahead and finish up with 2 more slides just to talk about some of the products that HP has developed for the OCP specification, or for customers that are wanting OCP equipment. So the first thing to think about, or I would like to make everybody aware of, is that HP and Foxconn announced a partnership that we established in May 1st. And basically what this partnership does is it is a partnership to go produce servers that are optimized for the internet service provider customers, or for customers that are setting up a cloud environment that want what we'll call bare bones servers that basically have a right-sized or cost-optimized feature set and are efficient in power and designed to optimally operate in a scale-out clouded environment. We think that the HP-Foxconn partnership offers a chance to basically go lead, be the leading server provider of these types of servers. And what it does is it essentially brings together the leading manufacturer of electronics equipment with Foxconn together with the leading server provider, HP. And it allows us to offer the best of both worlds. Foxconn does everything from roll their own sheet metal to producing electronic motherboards and electronics equipment, and HP has design capabilities that it brings to the table. Both companies have a very strong supply chain, and then HP offers global service and support. So we think that this partnership offers customers the best of both worlds. It gives them a very stripped down, bare bones server model that's right featured and right costed, but with worldwide service and support. And it's the reason why I mentioned this partnership is because it is through this joint venture between Foxconn and HP that HP and Foxconn together will actually bring to market the OCP servers that will be offered by HP going forward. And that's why I wanted to take a moment to provide that bit of background before we go to the next slide. So on the next slide, I show some of the servers that HP has offered for OCP, and I'll talk a little bit very briefly about some plans that we have going forward. But if we go and we look at this, the first thing you'll notice is that HP actually has been providing OCP servers for large-scale OCP deployments since 2011. And the first OCP server that we brought out was actually an OCP server that was designed for the original triplet racks that I spoke about. And that's the server that you see on the top. And basically you had a 1.5 rack unit high chassis that accommodated 2 servers inside of that chassis, and it had a self-contained front pluggable power supply. So this did not have distributed power in those original triplet racks. But that was actually the first OCP server that HP brought to market. It did use the OCP power distribution scheme that was available at the time, which basically took 480 volt 3-phase power and ran it through essentially a Y transformer to break out 277 volt AC to the servers as one input to the power supply, and then you actually had 48 volts coming in. So it was a bit of a unique power distribution scheme, but that was how the first generation of Open Compute servers were designed. In the middle, you'll see the HP ProLiant SL2150. That was the first server that was designed for Open Compute for use within Open Rack. So when the first Open Rack came out that had actually distributed power, as we discussed, you have a power shelf that distributes then 12 volts across bus bars to each of the server. These were the first servers that were designed for that type of a rack design. And so what you see is that this point with Open Rack, you've switched over to using the other dimensions. You've got 21-inch wide from rail to rail inside, but you're now measuring the servers on open units. So this was a 2 open unit high shelf that accommodated 3 servers across, or what some people will call third width servers. And so you can see the picture of that, see the 3 servers going across the shelf. So that was our first design that we developed for Open Rack. And I'll come back and I'll talk about where we're headed going forward very briefly in a moment. But I also want to talk about the HP ProLiant SE2140W. So in January at the Open Compute Summit in California, Microsoft also put a design into the Open Compute community. And this is different infrastructure from the other infrastructures talked about, because this infrastructure actually goes in standard 19-inch racks. And what Microsoft has is they have what they call a chassis kit that they've defined, which is basically a 12U set of chassis walls and power supplies and fans that accommodate 24 half-width servers. And so that's what you see on the bottom row there. You can see the server tray to the left, the half-width server tray. And then you can see a rendering of the 12U chassis kit with the 24 half-width servers. And of course, you could have multiple of those chassis kits in a rack. This specification, as I said, was different. It fits in a standard 19-inch rack. The power supply system that's basically in the back is it's got power supplies that are all shared across the 24 servers that are in the rack, and then it's got a set of shared fans or a fan wall that's in the back. So the form factor and design is somewhat different. There's also a chassis manager that Microsoft developed that manages fans and power, and essentially manages the infrastructure that's shared across those 24 servers. And Microsoft put that into the Open Compute Foundation, or put them out and available in the Open Compute arena. So that was a different variety of Open Compute server that was introduced in January. So as I mentioned, going forward, HP, with our partnership with Foxconn, will be bringing out a set of standard 19-inch servers within this line of servers that's designed for cloud environments that we're bringing out with Foxconn. But a subset of that product line will be Open Compute servers. And so as we bring out our next generation of Open Compute servers, you'll see them come out in that product line. Okay. these are the slides that I had, and what I'd like to do is I'd just like to open up for questions at this point, and we can spend as much time doing Q&A as we need for the next 20, 25 minutes. Nicole, do you want to open it up for questions?
Yeah, absolutely. And just a reminder, everyone, that it's really easy to ask a question using the webinar software. You should see a box on the left of your screen next to the slides where you can ask your question, and I'll make sure that I can pose it here to Curt. So we've got a few questions already. The first question I've got is airflow reversed on all servers for OCP?
I would not use the term airflow is reversed. These are still front to back airflow. So it's standard. It's a standard front to back airflow model. What I called out earlier, just to make sure that there's no confusion, is that the servers are front cabled, and so this is not a many customers are okay with front cabled servers, but when it comes to the network switch now. If you've got standard 19-inch servers where the network connections are in the back, typically your network ports on the switch are in the back. And so as you turn the switch around, essentially, to put the network ports facing the front of the rack because you're going to have front cabling, you've just got to take that into consideration. And there are many network switch vendors that sell one SKU of their network switch with airflow in one direction, and then you can essentially, there's a second SKU of the switch that rotates the switch around and has the airflow going in the other direction. And so that was what I stated. But open compute servers themselves, you're still going to deploy a rack of these, and your cool air is going to come into the front, and your hot air is going to exit out the back. It's no different in that sense.
Okay, great. Thanks. The next question we've got here is, are there open storage options?
Oh, that's a great question. There are open storage options. So essentially what the Open Compute, as I mentioned, storage is one of the work streams that the Open Compute Foundation has. And the first product that came out is basically a JBOD, so it's direct attached storage for the servers. The ones that you see on the market usually have 15 drives in one rack unit or one open unit, and most of them are 2 open units. So you've got 30 drives total in the JBOD. Usually the JBOD is able to be split amongst a couple servers. HP does not offer a JBOD today, but it's something that's under consideration for our OCP roadmap going forward.
Okay, great. The next question I've got here is, what is the advantage of OCP servers in terms of performance? Why would end users want to use them over conventional servers?
Well, performance that's a harder question to answer, because most of the OCP servers that are, let's say, in production today are 2-socket Xeon designs, or there's one flavor that's got 2-socket AMD. But when you take a basic 2-socket Xeon server, as long as you configure that equally between an industry, let's call it an industry standard or 19-inch server, as long as they're equally configured and your BIOS settings are set right, they're more or less going to perform the same.
Okay, and then maybe if you could answer the second part of that question, which is, why would end users want to use them over conventional servers? Maybe just speaking from your experience at HP.
That's a question that I think that is up to each individual customer to go and look at and evaluate. You need to take into consideration, I think, all the things that we've talked about within this presentation. The context that the question was asked, was in terms of performance. There's no performance difference. Whether a customer thinks that this is the right answer for them, within their environment, these servers are designed to have low cost structure and be power efficient. But there are multiple ways to get low cost structure and power efficiency, and you can do that within the 19-inch realm or industry standard realm as well. It's just a question of whether this is a type of infrastructure or whether the open path is something that buys you something tangible for your company.
Okay, great. Thanks. So I've got another question here. What else can you tell me about the Microsoft Cloud Server?
Let's see. The Microsoft Cloud Server, as I mentioned, was publicly introduced or thrown into the Open Compute Forum in January of this year. And let me just describe the infrastructure a bit, and let's see if I cover things that are that are interesting to you or interesting to the person asking the question as we go through and talk about it. But as I mentioned, the chassis are essentially in increments of 12U, or the chassis kit is a 12U chassis kit. In each U there are 2 servers, so these are 2 half-width servers side by side for a total of 24. As you look at the rear of the chassis kit, again, it's very basic. It's sheet metal, it's fan wall, and it's power supply backplane, essentially, where the power supplies plug in the back. So on the front, you would see 24 servers, 12, 12U, each U with 2 servers side by side. If you were to turn around and look at the rear, you would see a wall of fans on one side, and you would see, basically looking at that drawing that I have up on the screen, you would see in the left rear, if you're facing the front, is where there would be a row of power supplies going up and down vertically, up and down the system, and the power supplies plug into a backplane, and they're standard AC supplies that then will deliver power to the servers. As I mentioned, there's a management unit that plugs into it that essentially allows you that manages the fans and the power to each server. The one thing that you would note is that there's not cables that plug into the front. It is basically, or I'm sorry, there are cables that plug in the front, but basically the servers blind mate in the rear. So that's the one thing that's a little bit different about it, is that it has connectors in the rear that basically mate into a backplanes that are in the rear.
Okay, thanks. Okay, so the next question I've got here is there an energy savings or increase in power efficiency that comes with Open Compute?
Yeah, that's a popular question, and of course, when it comes down to energy savings or power consumption savings, very much depends on what bar are you comparing it to. The original Open Compute had a scheme basically where they were taking 480 volt, 3 volt, and 480 volts, 3-phase AC power, and breaking off each phase of the 480 volts to very efficiently break out 277 volt. That it was interesting. The running the power supplies off of 277 volt brought a little bit of increased efficiency as well. But there's other ways to go get power efficiency. High voltage DC is one that's talked about a lot right now. Can you distribute high voltage DC? And that will buy you pretty much very similar efficiency gains in power. I think more what Open Compute did was it challenged the industry, to make sure that they were staying on top of their game, or that they were thinking about ways to go deliver power more efficiently. And I think that Open Compute did a fantastic job of doing that, really just challenging the industry. It also caused us to go solve problems. For example, if you line up thousands or tens of thousands of servers that are all the same, performing the same function, you'll actually start to have problems with harmonics on your power grid. And there's a spec for something called total harmonic distortion. And this was a problem that we as engineers never used to think about. When you're in a very heterogeneous data center with lots of different kinds of equipment that are performing different functions, you don't really have that issue. But at massive scale, when you put lots of servers out there that are all the same, doing the same thing, you do have to worry about concerns like total harmonic distortion. So it also, maybe not open compute in and of itself, but these types of deployments caused us to think about problems like that as a community.
Okay, great. The next question we've got here is, does Open Compute specify server chassis form factors?
Yeah, that's also a typical question, or a very good question. And it actually doesn't specify the exact form factor. Again, if you go back and look at what the work streams are, the work streams specify the rack, and there's a work stream that specifies motherboards. But the exact dimensions that you see the sheet metal in, you will see some references out on the Open Compute website that refer to the chassis that goes around the third width servers, but they actually don't specify the exact chassis, and that's why you see some different types of servers that are out there. What they do specify is the motherboard. And then Open Compute certification in and of itself is something that is still, let's say that the specifications around it and how do you declare something Open Compute or certified are still being worked, but you're starting to see some folks that are putting rigor around that within the Open Compute community, but it's not fully formed yet.
Okay, thanks. Okay, so our next question is, there's been press coverage around big companies rolling their own servers. Is OCP just another way to do that?
So that goes back very much to the question about with OCP. I think that the initial thought around OCP was to get components out there that, one, were open to the quote unquote open to the community, and that there would be multiple customers that would go use the same, actually some of the same components. If you start talking about rolling your own servers, the question is, what do you mean by rolling your own servers? If it is self-supporting your servers, there are Open Compute vendors that you can go buy from, and then you do have to end up self-supporting. If it's truly rolling your own, where you're designing your own, there are companies that do that, but they tend to not be as open about it. Open Compute's more about community leveraging what's in there. Companies that decide to roll their own, those tend to be proprietary designs, and that's yet another variety of model or another way you can go. And you can see some of my initial comments. If you're looking at an Open Compute server and you're thinking, I almost like it, but I want it to be slightly different. I want more hard drives in it, or I want different hard drive cages or different PCI configuration in it. Like I said, you've got to ask yourself the question about, do you have the volume to go justify doing that? And that statement that I just made in general would apply to rolling your own.
Right. Okay. Okay, I've got another question here. Bringing 480 volts to the rack may be unsafe. What standard does OCP have to make the rack safer around IT personnel? Okay, I'm not a voltage safety expert, but there's basically a 240 volt VA rule regulation that we have in the industry for safety, and as long as you're meeting that 248 volt safety rule, or you're protecting voltages that could potentially exceed the 240 volt VA. And what I mean by protecting is protecting it from a customer touching it. You're meeting, again, I'm not the expert on it, but you're meeting basic safety rules. In terms of delivering 480 volt three-phase, in a data center itself, there's many data centers where 480 volt three-phase rather
is delivered to the rows, and then the rows basically will break out the AC voltage that is delivered to the individual racks. So that voltage is in your data centers today. It's just it's handled in different ways. When you get into the individual racks, or more importantly, when you get into components that service personnel, for example, could touch or put their fingers on, there are safety rules, by law or by regulation that you're required to meet.
Okay, thanks. All right, so we've got a couple more questions here. The next question is, are OCP racks typically designed with captive UPS?
Are OCP racks typically designed with captive UPS? It's a great question. I've seen many OCP racks that don't have the UPS captive inside them. So no, they're not all designed that way.
Okay. And then the last question we've got here, I think, is a great question to kind of end this presentation on. And it is, what is the future of OCP? Is it here to stay and or evolve? Should colo data centers adjust for them?
That's a great question. It's one that I think a lot of people are asking. It very much depends on the uptake of OCP with customers over the next year or two. Is this something that's going to gain traction? Are the offerings generally applicable enough so that people can go this route? What server providers are going to support? How are they going to support this, or how does the customer want to be supported? Do they want to go more to a self-service type model? These are questions that I can't answer. It really depends on the consumers and how they take up OCP and how OCP is supported as to whether it takes off.
Right. Yeah, it's a pretty big picture, broad question, but I think it's a good one, and one that a lot of people are discussing for sure. So that looks like all the questions we've got. Just a reminder, the archive of the webinar will be available. You'll get an email. And Curt, if someone comes up with a question after the presentation and they want to get a hold of yourself or someone else at HP, where can they go for that information?
If there's someone that has a question on OCP, first of all, there is the OCP website out there that is a good resource around just some of the basic specifications. But you can see that folks can either contact me. There's Curt.Belusar@hp.com. There is also a person within HP Marketing, James Hyde, and you can contact him. And that's james.hyde, Hyde, @hp.com.
Okay, perfect. Well, thanks so much. That's all the time we've got for today. I'd like to thank everyone who attended the presentation and for all those questions that you submitted. And of course, I'd like to thank HP and Curt for being here today and presenting on those top 5 considerations for transitioning to open compute. Thanks again, everyone, and have a great day.
My pleasure. Thanks.
Take care.